Welcome everybody to Math 1314, more on math. Chapter 4, Section 5, Solutions. Alright, let's look at this. And the first one. It says, determine the domain of the function f of x equals x squared over 8 minus x. The domain of any polynomial is usually negative infinity to positive infinity. Unless an x value makes it undefined. Okay, so the way a fraction can be undefined is if the top is set equals 0, those are your x-intercepts. If the bottom is set equal to 0, those are restrictions to the domain. So, to find the restrictions, we take the bottom number, set it equal to 0. Add x to both sides. We got 8 equals x. So, we know since it equals 0, the only x we cannot use is 8. From negative infinity to... So, what we have here is we have a function that goes from negative infinity to 8. And then it starts up again at 8 and goes to positive infinity. That's the domain. So, find the domain of this one. Since top can't be 0, we don't have to worry about it. Let's look at the bottom. X squared minus 2x minus 36. We said that equals 0. So if we factor this one out, because the second sign's a minus, that means we have opposite signs. And when we factor this, the bigger number in these parentheses, we'll get the negative sign. So what times what is 36? What times what equals 36? When you subtract them, you get 2. Alright, so I'm sorry, it's 35. It's 35. 7 times 5 is 35. 7 minus 5 is 2. So the answer is 7 and 5. So since that's negative, the 7 is bigger, it goes there, and 5. So what makes this 0 is if x equals negative 5 and if x equals 7. So these are the numbers I cannot use. So my domain goes from negative infinity to negative 5. Then between negative 5 and 7. And then from 7 to infinity. So the only numbers we cannot use are these numbers. Number 3. Determine the domain of the function. 5x minus 7. 5x plus 15. The reason we factor both top and bottom is just in case anything cancels out. If anything cancels out, then that's no longer affecting our function. So the top can't get factored, so it stays at 5x minus 7. The bottom, they both have a 5 in common. So if I factor out a 5, remember it's like dividing, I get x plus 15 divided by 5 is 3. So I set that one equal to 0. So x equals negative 3. So x cannot equal negative 3. So we go from negative infinity to negative 3. And then from negative 3 to positive infinity. There's my domain. So far so good. Excellent. Now, asymptotes. Well, whatever our restrictions are, whatever we can't use, so negative 3 is, since it's x cannot equal negative 3, negative 3 is our vertical asymptote. So you can say an asymptote, a vertical asymptote, are x's that make the bottom equals 0. So all we have to do is take the bottom and set it equal to 0. So x squared minus 9. Well, it's only two terms, so you go ahead and add 9 to both sides. So we have x squared equals 9. Square root both sides, so we have x equals plus or minus the square root of 9 is 3. So my vertical asymptotes are at 3 and negative 3. Now, remember it said all asymptotes. So my vertical asymptotes are 3 and negative 3. So x, this can't be it. That can't be it. So it has to be one of these two. Now, the horizontal asymptote. Remember for your notes, it all depends on the exponents of the leading term. If the top is bigger than the bottom, then there's no horizontal asymptote. If the bottom is bigger than the top, then the horizontal asymptote is y equals 0. And if they're equal, then the horizontal asymptote equals the coefficients, a over b. So all we look at here is 7x cubed over x squared. Since the top is bigger than the bottom, there's none. But if the top is bigger than the bottom by 1, then we have an oblique asymptote. So all we do here is we just do long division, but in this case it's just simple. So the oblique is 7x. So it can't be that one because it's negative. Can't be that one because it's negative. Can't be the first two because they're negative. This one, D, is too slow because it's 7 times x, so it's a very steep one. So it's got to be C. So that's what the graph's going to look like. We have a horizontal asymptote at 7. That's the oblique asymptote. We have vertical asymptotes at 3 and negative 3. So, and if we plug in some numbers, if we plug in 4 inside our equation, we'll see that our graph has to stay inside there. Or if we put negative 4, we'll see that our graph has to stay inside here. In the middle part, when x is 0, we get 0 over 9. If we put in 1, we'll see we have a negative answer. So we know the inside will look like this. But it didn't ask us to actually graph it, just look for it. So we just plot some points. Find the vertical asymptotes of the function. Remember, vertical asymptotes is the denominator set equals 0. Yes, we have it twice. That's the multiplicity. So x is equal to 1 is our 0 of multiplicity 2. So the function has 1 vertical asymptote, or 2, it has 1. And it equals 1, or x equals 1. That's the vertical asymptote. Okay, next one, vertical asymptotes again. So we have 1 minus x equals 0. Add x to both sides, so we have 1 equals x. So the vertical asymptote is 1, or x equals 1. So the answer is A. B says there's 2 verticals, and there's only 1. And C says there's none. All right, number 7. Find the vertical asymptotes of the graph. So that's where we set the bottom equal to 0. Since they were kind enough to factor it for us, we get x equals 4 and x equals negative 5. There are 2 vertical asymptotes, so it's not A. So the leftmost asymptote on a graph, the leftmost is negative 5. And the rightmost is 4. Number 8. List the domain and the x and y-intercepts of the following function, and then graph it. So the domain, remember, the domain of any polynomial is usually negative infinity to positive infinity. But since x is on the bottom, we set it equals 0. That makes the bottom 0, and we cannot have that. So my domain is from negative infinity to 0, because I can't use 0, and then from 0 to positive infinity. So that's your answer for that first question. to find the x-intercepts, what are the x-intercepts of the function? X-intercepts the numerator set equals 0. But since the numerator is a constant, it has no x-intercepts. Since there's no x-intercept, you cannot have a y-intercept. Because in order for it to have a y-intercept, you have to have an x-intercept. Find the vertical asymptote. The vertical asymptote is where the bottom is equal to 0. So since it's x, set that equal to 0, there's a vertical asymptote. Find the horizontal asymptote. Since our function is negative 6 over x, there's more x's on the bottom. So the horizontal asymptotes, since our function is this, it goes to 0. So as x gets large, the number gets smaller and smaller and smaller and smaller. So it goes to 0. Does it have oblique? No, because obliques only happen when there's one more on top than the bottom. So it has no oblique. And our function, remember, is negative 6 over x. And we did a function like this earlier this semester. In the library of functions, since it only has one x, this on the bottom, it looks like this. Remember that graph looked like this. But since the coefficient is negative, we flip across the x-axis. So it looks like this now. So it can't be a, because this is x squared, 1 over x squared, so that's not it. This is just 1 over x. We can't have that. This is negative 1 over x squared. So it has to be C. The last question. List the domain, x and y intercepts, and graph the function. So the domain, since let's look at this. We have x plus 3. We have to factor the bottom. X squared minus 9. 9 itself is 3 times 3, so it's 3 squared. So we have the difference of two squares, so it's x plus 3, x minus 3. So the bottom is x plus 3 times x minus 3. So this polynomial factors that into that. Well, these cancel since they're x plus 3's, so we're left with 1 over x minus 3. So now once we cleaned up everything, this is the function we look at. We set the bottom equal to 0, so x equals 3. So that's our restriction. Our domain is from negative infinity to positive 3, 3 to positive infinity. That's our domain. X-intercepts. Do we have any x-intercepts there? So remember, what defines an x-intercept in our function? The only way you can have an x-intercept is if the top equals 0. Factor that out. Remember, x-intercepts are zeros are effective. Since our equation we're looking at is 1 over x minus 3. Since the top can never be 0, there's no x-intercept. How about a y-intercept? To find the y-intercept, set x equal to 0 of this equation, the simplified one, and solve. So we have 1 over 0 minus 3 equals 1 over negative 3. So the y-intercept equals negative 1 over 3. It has to be an ordered pair, so it's 0, comma, negative 1 over 3. That answers 0, comma, negative 1 over 3. There. Find the vertical asymptotes. So remember, our function is 1 over x minus 3. So x minus 3 set equals, like the bottom, set equals 0. So that's my asymptote is at negative 3. Is at 3. It was x minus 3. So it's at 3. That's my vertical asymptote. Horizontal asymptote. Since our function is 1 over x, there are no x's on top, then we have no horizontal asymptote. Our horizontal asymptote is 0, since we have that function. As x gets bigger, this one goes to 0. So our function that we're dealing with is 1 over x minus 3. Remember, this basic function is 1 over x. Look like that. But the bottom is shifted. Shifted where? Set that equals 0. It's shifted to the right 3 spaces. So my graph will look like this now. But one more thing, when we do the graph, remember on the very, very, very top, we canceled out the x plus 3's. We need that here. We canceled out the x plus 3. Set that equal to 0, we get x equals negative 3. So plug in negative 3 in that equation. So we have 1 over negative 3 minus 3, which is 1 over negative 6, which means at negative 3, negative 1 over 6, we have a hole. That's where a asymptote used to be till we canceled it out. So our graph, 1, 2, 3, there's an asymptote there, which means our graph looks like this. And at negative 3, at -3, there's a hole in our graph. So if you cancel anything at the first part, then that becomes a hole. So when you finish the whole thing, take the simplified version, plug in the number that you factored out, that it canceled, and that's what you have, the hole at that point. All right, good luck, everybody.